My Ford Granada 2.8 liter with a Cagetronic fuel injection system have been running really bad since I bought it for about 10 years ago, and I've been checking all the normal things that I normally think can cause the engine to have a lack of performance, and the engine was actually running smooth and don't have any misfiring and stuff like that. It just had a really lack of power. And I've also been talking to many other people that are working on old Fords, and most of them say that it is the Cagetronic system that caused this main problem, and some others say that it is the camshaft that is probably worn out, because that is a common problem for these engines. And the rest of the people I've been talking to say that I have to check everything that I already have done. So now I'm making a full documentation video of the Cagetronic system and hope that that can help others. And this video is actually a part of that documentation, but suddenly I found out that I was just talking about the ignition system. So I choose to separate this from that video. So if I'm talking about things that I've already done, then I refer to the other video that is not ready yet. But I think that it is good to just have a full check on the system when these cars are getting this old, because especially the warm-up regulator, I see it is really fragile to hot and cold environments and vibration and stuff like that, I think, and I'm actually surprised that it wasn't more off as it was. But I can mention that I found out that the injectors was not right. It was different injectors with different opening pressure. I had the vacuum leaks, the hose that goes from the fuel distributor to the throttle body was a Volkswagen hose that was full of tape. And I also had some leak to the inlet manifold gasket, and that was full of RTV. And what more was it? It was the fuel accumulator that was toast, so it was really hard to start this engine when it was warm. And the control pressure on for the fuel was too low, so the engine was getting too much fuel. So it was actually different things that made some improvement. And before I did those things, the engine was actually stalling when I was engaging the transmission, unless I had it running on like 11 and 1200 RPM. So I think this can be useful information to others anyway. But the main problem was actually the ignition system. And now I will just show you how this engine was running just before I did this last change. Okay. It's slow. Come on. Doesn't feel like a injection 2.8 liter. So today I will start with the ignition, and as we know, I already set the timing, and as I said earlier in this video, I already have replaced the spark plugs and the spark plug wires, and I also replaced the rotor and the cap on the distributor. And what I didn't mention was that the rotor and the cap was actually not fitting on this distributor. The rotor was too high, so it was actually touching the contacts in the cap, so that's not very good. But now all these parts is replaced, and the next thing I will check now is if the coils seem to be okay. Now I will first unplug the power connectors and the spark plug wire from this coil. Now this was interesting. This condenser here is not connected to ground, then that one won't have any function, of course. I will also just unplug this condenser from its connector here at the wall. Like that. And now I can just zoom in a bit so it will be easier to see. And now we can measure the primary and secondary winding on this coil, and the primary winding should have 1.1 to 1.3 ohm, and now this is in auto range, so that's good. Then just measure between both these power connectors on the top and the bottom, and that is 1.3, 1.4 ohm, and maybe I have some resistance here also, 0.1 ohm. So if I just take that away, then that would be in range, and the secondary winding is should be between 7.5 and 9.5 kilo ohms. So if I just put this pin in the middle on the spark plug wire out, and on one of the power connectors I have 8.89 kilo ohms, so that's good. And you can just do it with the other pin also, but that should be the same. Ah, come on, bad contact. Wasn't that easy? There, 8.69. And now I can just also measure this condenser, and it's rated to 2.2 microfarad. And then I just put this into the capacitor measuring, and then put the negative to the ground and the other one to this pin here. That is 1.95 microfarad, so that is pretty good, about 10% off. And of course that will be the same if I measure on this pin here, as those two have the same potential, 1.95. And if I then put it to ohm, then I can actually see if this is charging and discharging. Come on, contact. Yes. And if I just swap them over, then it's going the other way. Yep. So most likely this one is good, and I can of course also just measure between these two here, and those should have good contact, and that is 0.1 ohm, which is the resistance on these pins. So that looks like it's good. And then we can of course also, just for safety, discharge it. I also found out that the lower mounting screw for this bracket for the ignition coil is missing, so it's quite loose, and I guess that this condenser is supposed to be connected to that screw. So now I found a new screw that I will mount on this bracket, and also attach this condenser when I put everything back together. And the next thing I will do now is to just measure that I have about 8 volt on the power connectors for this coil. And the reason for why we have about 8 volt is because the power is reduced because of it's going through a ballast resistor cable. Unless when we are starting the engine, then it gets full power. So that's the next step now. As the ballast resistor is a current limiting device, the power connectors need to be connected to the coil to complete the circuit. And now I found these test leads with this crocodile clip, as we call it in Norway, or I think it's alligator clip in English, or maybe they use both. But anyways, now I connected the negative to the negative on the battery and the positive to this little lead that I put into the connector for the positive on the coil. And now I will just turn on the ignition and see how many volts I have. So the reading was a bit low as the alternator is not running. So now I connected this battery charger to the battery, and hopefully now the voltage will increase. So the voltage to the positive side of the coil was increasing as the battery charger was connected, but I didn't want to put the battery charger to boost as that would provide too high voltage, and I also didn't want to let it stay connected for too long to charge up the battery with the ignition on, as I remember that a friend of mine who was visiting here with his Volkswagen T2 bus let the ignition stay on for a while, and then the coil was actually overheating and melted, and I certainly don't want to do that to my coil now. So I had that in mind when I did these measurings. And you would probably say that those measurings that I've just done is not that accurate, and I can kind of agree to that. But now I see that the coil gets its power through the ballast resistor, and unless I try to start the engine, and that it don't receive 12 volt, which would make it overheat. And I could of course also disconnect the ballast resistor to measure that it has 1.1 ohm. But I think that if the engine was running and the alternator was spinning, then the voltage would be better. And I could of course also have connected one of my oscilloscopes and try to do even more accurate measuring. But none of my oscilloscope has the range to actually test the output of the coil, so it wouldn't be that accurate anyways. So I think this is good enough, and now I see that it is a 7 volt coil because the primary winding has the correct resistance. If it was like 3 ohm, then it would probably be a 12 volt coil, and then it would receive too low voltage. And of course the measuring I did also to the condenser is not maybe don't test it directly, but it tells that it seems to be okay. And the last thing is actually the DuraSpark ignition module that amplifies the voltage, and I don't think it's a problem to that either, as the car is running smooth and I don't have trouble starting or anything like that, no misfiring. So I think that those parts is good. The next thing I will check now is the timing, and I already know that it's set to 12 degrees before top dead center, but now I will check that I actually get the right amount of advanced ignition, both mechanically and with and without vacuum. And to do that I now borrow this more professional timing light from a friend, and that also let me see the RPM on the engine, which is very helpful. And this also let me set the timing to 0, not the actual timing on the engine, but if I type in 12 degrees before top dead center here, then it will like put in a delay, and the light will actually blink on the zero mark on the engine, and that will of course then still be 12 degrees before top dead center, but it's set to 0 now when I'm going to do this reading. And that has to be done because if not, I will be out of range on the scale on the engine when doing this test. And the first thing I will just check now is that the timing is still set to 12 degrees before top dead center by plugging off the vacuum hose on the distributor and plug it, and then just have the engine at idle speed. And of course I will first warm up the engine before doing this test. So now I've prepared my setup, and I will show that after the engine is at operating temperature. But first I thought that I just should show how easily this engine starts at first attempt after it has been standing for a couple of days. So now the engine is warm, and here is my setup. And I'll hook this timing light up to the battery, and now it shows 12.7 volt. And I also disconnected the vacuum hose that goes to the distributor, and now I just put on these longer hoses so it will be easier to access. So this one is going to the distributor, and that will not have any vacuum now. And the other side of that hose is now plugged. So now the engine is idling, and let's just check the timing. So that was still at 12 degrees, and now I will set this to 12 degrees. And now I should read 0 degrees, and I will make sure that I read 0 degrees before I continue the testing. And the next thing I want to check now is how much mechanical advanced ignition timing I have. And I will then have the vacuum hose still disconnected to the distributor to just have the mechanical advanced timing. And now I will increase the engine speed to 2000 RPM, and then I should have between 13 and 19 degrees advanced ignition timing. So that was not looking good at all. The timing was actually a little bit retarded, and I should have a mechanical advance. So now I will just do one more test and increase the engine speed to 3000 RPM just to see what happens then. So that actually caused the timing to be retarded by 3 degrees, and I should actually have a mechanical advance of 15.8 to 22.3 degrees at 3000 RPM. And this is also what happens when I'm driving at 3000 RPM and then give full throttle, and then I will lose all the vacuum and only have the mechanical advance. And therefore this of course will cause the engine to have a lack of power. So I have to open the distributor and see what's going on with the weights. But first I will also just check the vacuum advance. So now I will just do an easy vacuum test. And now this vacuum tester is still connected directly to the distributor. And first I will just pump some vacuum and see that I don't have any vacuum leak, and that the vacuum is stable, and that it is. And then I will just release the vacuum. And then I could actually hear that the distributor is turning back inside. I don't know if you can hear it on the camera, but I can try once more. And the next thing I will do now is to just start the engine and set the engine speed to 1000 RPM. And then I will pump this vacuum gauge to, let's say 7 inches of mercury. or 240 millibar, as that would be more correct to say here in Norway. And then I should have a vacuum advance of 7 degrees to 14 degrees. So it looks like the vacuum advance works as it should. It gave me an advanced timing of 9 degrees, which is good. And now I just connected the vacuum hoses back together like there was before. And now I'm just going to start the engine and let it idle and use the timing light, still set to 12 degrees. So we will read from 0 degrees, and then I will just see what it says, and then I will increase the engine speed to 2000 RPM and then 3000 just to see what happens. So that was a bit surprisingly. I didn't expect that much advanced ignition timing at idling because of the vacuum. So I will probably have to check that also. But that will not, of course, cause this engine to run this bad at full throttle, as I then will have no vacuum and no advanced timing because of the vacuum. But when I increased the engine speed to 2000 RPM, then I saw that the ignition timing was a little bit retarded, and at 3000 RPM then I saw it was at actually retarding 3 degrees like it did without the vacuum connected and just mechanical advance. So that is still the same. So now I'll just have to find out what causes these problems. So I had a beer again last night and I was thinking of why haven't I noticed this before? And the answer to that is that I only made sure that the timing was set to 12 degrees before top dead center. And then I hooked up the vacuum hoses, started the engine and was revving it a bit. And then I saw that the mark on the pulley on the crankshaft was passing the end of the scale on the engine. And then I had more advanced ignition and everything looked good to me. And I didn't have that more checked than that. And of course I didn't had a throttle fully open, so I would lose the vacuum advance. But now it makes sense why I had that much advanced ignition timing, because I had those 12 degrees advance plus those 9 degrees vacuum advance, and that would be 21 degrees advanced ignition timing, so I was out of the scale. And now I can also explain why I think that I have this lack of power, and that is because when say I was riding up a steep hill at 3000 RPM at full throttle, and then I would have a vacuum, not a vacuum advance, but a mechanical advance at 20 degrees, to just say an easy number, plus those 12 degrees advance, and that would be 32 degrees advanced ignition timing that I should have. But what happens now is that I have those 12 degrees advance, and when I have this mechanical retarded not advance at 3 degrees, then I was actually down at 9 degrees. So that would say I would be 23 degrees off, and that's pretty much. The pistons would be pretty far way down, as the crankshaft have been turning 23 degrees too much. So I would just say pour this engine, and this also explains why I had an increased fuel consumption, because when I was riding with a friend to a car meeting and he had a 3-liter Gia, and I have an injection which should be more economic to drive, and he was using much less fuel than me, so that was pretty unfair. And the last thing I was thinking about is the vacuum. I actually think that that is hooked up the wrong way, when I replaced all the vacuum hoses, I only took off one hose at a time and replaced it. I didn't check anything more than that, but I actually think that someone have set up the vacuum hoses the wrong way, and now I will just show you that. So now the engine is at operating temperature again, and the first thing I will show you now is how far the mark on the pulley on the crankshaft actually passes the scale on the engine at 1000 RPM. When I set this timing light to 0 degrees, so it will show the actual advanced ignition timing. And in case someone wonders, as I not mentioned it, is that I of course set this timing light to 6 cylinders. So here is what I don't understand. This vacuum hose is of course connected to this throttle body and should not have much vacuum when the throttle is closed, and that is not going directly to the distributor. It's going to a T-coupler here. I haven't put this all the way down yet because I'm going to take it off again. And this one is going down to the distributor, and it is a T-coupler here. And the other one is going, it's not that easy to film, but it's going into this plenum chamber box at the connection at the side. So, as I see it, this distributor will have pretty much manifold vacuum when the throttle is closed because of the other hose that goes down to the plenum chamber, and it will suck some air from this hose also, and when I have the throttle fully open, then of course the whole manifold vacuum will disappear. But I don't think that this T-coupler should be here. I think this vacuum hose should go all the way down to the distributor, and if I'm correct, I think that this is going to have very little vacuum now, and when you open the throttle a little bit, then it will suck vacuum from this plenum chamber from inside this throttle, and of course when we're going towards fully open throttle, then we will lose the vacuum. So I will test this also after. So now I will check how much vacuum the distributor receives when the engine is running. So now I disconnected the hose that goes to the distributor and connected this vacuum tester to that T-coupler where the hose to the distributor was connected. So the vacuum was high as I was suspecting. So the next thing I will check now is how much vacuum I get at the plug at the throttle body. So now I connected this vacuum tester directly to the throttle body, but the vacuum hose for this vacuum tester was a little bit big and I didn't have a straight reduction connector, so I had to use this splitter. And now I also have plugged the other vacuum hoses, so I won't have any vacuum leak to the manifold. So to me this seems to be right. Then I will only have a vacuum advanced ignition timing when the throttle is partly open or open in a certain range, and when it's fully open or when it's closed, then I won't have any vacuum advanced ignition timing. So the next thing I will do now is to just open the distributor and see what's going on to the mechanical function that gives me the mechanical advanced ignition timing. Since I've already shown how to take out the distributor and put it back in and adjust the timing, and I've just taken this one out. There's no need to document that twice, of course. So now let's just get straight to the point of how to disassemble this distributor and try to find out what causes the mechanical function not to work. I've never disassembled exactly one of these distributors before, but I guess it's pretty much the same basic as the ones that I've been working on with points and condenser. First we just have to remove everything that is on top here to get down to the mechanical function. And I also now realized that it is actually a bit hard to turn around. So maybe this one just needs some cleaning. And that's also maybe what causes these weights to not freely spin out when we raises the engine speed. So yeah, okay, there it was a bit easier to turn around. So yeah, maybe just some cleaning, hopefully, and I hope then this one will be good again. So let's just start from the top and first remove this snap ring. Oh, it wasn't that easy. Come on. There, we got it. And here is a pin that prevents this one from spinning. So I think that this one is just sitting right down here, so I can just use a couple of screwdrivers to flip this up. Okay, it's sitting really good. And we should of course be careful to not bend it, because then it will hit these pins. But maybe just have to work around it. So it was actually sitting really hard, so maybe some lubrication would help a bit. Oh, this one is still pretty hard to turn around, and that is not good at all, of course. I'm pretty afraid that I will bend this, hopefully not, but if I do, then this one is gone anyway. Just carefully going around and around and hope that it will get loose eventually. Carefully to not bend it. Now I'm actually having a bit force on it. Okay, yeah. Okay, just careful now, but it's on its way. Just needed a little bit force. Okay. So that's how it's supposed to come off, I guess. And then just get this pin down here. Oh, that was little. This little pin here. And then I can actually see another snap ring that is placed down here. Let's just get that one out also. Like that. And then I need to find out if this connector should be removed first before moving this part here, so I don't damage any threads. Let's just think a little bit. Hopefully I'm not damaging anything now. I think I will begin by just taking this screw out, and there's another one that is placed just under this connector here, and then see what happens. And this part also comes off. So now it's important to just film everything in case I damage something or get it loose. 1 out of 2, only one attempt. That one, is that connected to everything? Or is this apart? Oh, don't damage those threads. So maybe I'm doing it wrong. What if it can actually be that easy? It's just to loosen those 3 screws here. Oh my god, I'm so stupid. It's that easy. Yeah, of course, we also have to take off these clamps here. And then, how do I disconnect this vacuum module if I can't remove this upper part? I will first just unmount the 2 screws on the side here to see if that makes any difference. So normally there is a C-clip that attaches this link arm, but I can't actually see how to access that, if that's the same here. So right now I actually like the points and condenser better, but yeah, there must be some way to get access to get this link arm off. Okay, so that was actually much easier than I was expecting. There is no C-clip, it's just to take it down, then it's loose, and then this also should come off. And that is actually how easy this is when you just know how it's put together. So here is this adjustable part, and now we know that this whole thing has to come off. And I was actually checking on my phone on Google, but I couldn't find any solution of how to disassemble these parts. So I thought I could just show you that also now. And what I found out after I actually disassembled this is that there is an edge here, so you can't get this arm off, and I thought that it was a C-clip like there usually is. But when you drag it all the way out, then this arm is free to get off. But when you take it back, then it's not possible to get this on off. And now I can also just show you how this arm works, as we get vacuum here inside this diaphragm, then that will drag and push this back as we have a vacuum or not, and then the ignition timing will be adjusted. So here are the two weights that gives us the mechanical advanced ignition timing, and they are both attached to a spring, and the tension on these springs and the weights is like a perfect calibrated setup to give us the right amount of advanced ignition timing as the engine speed is increasing, and then the weight will get further out, and then this middle part will like twist. But what I saw right away is that this is not functioning, because both these weights are just loose, and this spring here is tensioned, so this middle part here is stuck to the rest of the shaft, so this can't be working like it is now. So that's good to see that it's only need some lubrication, and I guess everything will be good when we just have done that and assemble this back together. I will also just mention at this point that this cloth thing in the middle here helps preventing this to dry out, and as you can see this is totally dry. So this is what can happen if you don't lubricate the distributor once in a while. Okay, just need to document this also. How much is this stuck? I can't move it at all. It's totally stuck. So let's just lubricate this plenty and let it stay till tomorrow. So now it is the next day, and now this shaft is spinning really easy. And now let's just hope that we can also loosen the top of this shaft. To prevent the shaft from spinning, I put the lower part of it in this vise, and of course I also have something in between to not damage this gear. This is still pretty stuck, unfortunately, so I just have to continue to try to get it loose. To not damage either side of this shaft or this top, I'm now going to make a clamp so I can use some more force on it, and the best way to do that is just to use a piece of aluminium. So then the first clamp was finished, nothing more complicated than this. And that one fits perfectly here now. Now we'll just tighten it up, and then I will have a perfect good grip. So now I made one more clamp for this other side. I didn't want to put it here on the edge of this shaft here. I wanted it to fit here in between, so it was a little bit more work as I had to drill a bigger hole and grind off some of the aluminium to make it fit here in between. So now I will just tighten that up also, and then I have a good grip on each side. So now I should be able to rotate this upper part. Yeah, it is movement, but that is pretty hard. It's not moving down at the end of the shaft, so that is full movement, but it's way too hard. So I think I have to try to get this upper part off and really lubricate this and then put it back together. So now I will loosen this flathead screw in the center here and both these springs on each side. Then I will mount this clamp again, so we can use that to drag this one up. Ah, smooth. That wasn't hard at all. So let's just clean this. Ah, that was pretty... yeah, doesn't look good. Let's clean it and then put it back in. So now I cleaned everything inside here as good as I can without disassembling everything. And now this top here goes down like that. Now this opening here is facing towards here as it did before. I made sure of that. And now this one is spinning freely. So let's just lubricate this with some oil. And then everything is just a reverse process of disassembling everything, so I don't think I will show all that. Just a little detail. There is a washer that goes on first here, and I didn't show you that, so just don't forget that one. That goes on first. And I also made sure when I took off the top here that this side of the shaft is facing the same way as it did when I took it off. I don't know if this matters because this one is of course spinning, but just to be sure I just made sure that it is in the same place. So now everything is moving easily here and the top of this shaft is going back as it should. So that is how it's supposed to be. So now the distributor is finished and rotates very easily. And now I also checked that the distances between the rotor and stationary arms seems to be the same. I don't know what the clearances should be, but now the gap seems to be the same and no pins are touching each other. By the way, it won't do any harm to just retighten the bolts on the inlet manifold before putting the distributor back in, and when everything here is still disassembled, as we now also have driven this car. Now the distributor is back in, and I thought I just could show you how it looks like when the vacuum advance is working. So now I just hooked up this vacuum pump, and when I then pump vacuum, we can see that the stationary arms is rotating as I pump vacuum. and when I release the vacuum, and not that easy with one arm, then it's going back. So then I have vacuum again and release the vacuum. Oh, come on. There. So when I have a vacuum, like just pump some vacuum again. Now we have vacuum advance, and you see that the arms now is rotated a bit, and now we can also see that this upper part is spring loaded, so it goes back, and then we know that the top of the shaft here is not stuck like it was. So now we have vacuum advance, and when I rotate this all the way there, then we also have a full mechanical advance. So this is how it looks like when we have a total advance with both vacuum and mechanical advance. And then I can just release the vacuum again. And this is how it's supposed to work. This time when I mounted the distributor, I see that I actually have rotated it one tooth to the right on the gear. But I'm going to let it stay there because I actually think that this is the right position. And that it was turned a little bit too far left as it was. But this actually doesn't matter that much, because the important thing is that this rotor is pointing towards the mark here on the edge, and that we are able to twist the distributor enough to adjust the timing to 12 degrees before top dead center. And now this vacuum module have plenty enough space to adjust this. And also we of course have to make sure that these arms are free, so we can also put on the cap. So now everything is assembled again, and I set the timing, and the vacuum hose is still disconnected from the distributor. And now I will just start the engine and let it idle, and then just show you what happens when I increase the engine speed to 2000 RPM. So now we can see that we get mechanical advance, and this time I will set this to 12 degrees so we can read from 0 degrees, and then I will increase the engine speed to 2000 RPM, and then we should have a reading from 13 to 19 degrees, and then I will even increase the engine speed more to 3000 RPM, and then we should have a reading from between 15.8 to 22.3 degrees, which is more than the scale is actually showing. As you can see, we have a higher mechanical advance at both 2000 and 3000 RPM than the scale on the engine is actually showing. So this time I will raise this value by 10 degrees to 22 degrees. So now we will actually read from 10 degrees before 0. So we just have to add that to our reading. So if we now are reading like 10 degrees, then it will actually be 20 degrees. So now it was showing 8 degrees at 2000 RPM, which means 18 degrees mechanical advanced ignition timing. And it was showing 10 degrees at 3000 RPM, which means 20 degrees mechanical advanced ignition timing, which is a little bit higher. And I think that this looks good. And now I will just set this down to 12 degrees again, so we can read from 0 degrees. And then I will hook up the vacuum hose directly from the throttle body to the distributor, and start the engine and just let it idle, and just rev the engine a little bit, say just about 1000 RPM, just to see what happens then to the advanced ignition timing. I'm no expert, but I think that this now looks good. I of course could have done much more testing on different values on both the mechanical and vacuum advance, and I will probably do that later. But for now, I'm happy about this result. And I can also just mention that I of course didn't have to worry about the mechanical advance when I was checking the vacuum advance, when I was applying a vacuum to the distributor. Normally we of course have to subtract the mechanical advance to get the vacuum advance, just to mention that. But to me, as you know, the mechanical advance was stuck. So now I'm excited to see if this makes any huge difference. So now we'll just wait till tomorrow, then we are going to have a nice weather, and just then I will just have a ride, and hopefully this will make some improvement. Okay, so now I'm ready for a new attempt. I have to beat my old record, 0 to 80 in 33 seconds. So now it will be exciting. Just wait for the traffic to get away. Yeah, it looks good. Then just stop. Okay. Yeah, that was a huge improvement. Still not a rocket ship, but oh, that felt good. That was actually my first attempt, so yes, finally some real improvement. When I got home, I unfortunately saw that the GoPro camera didn't have enough GPS signal to show the speedometer, which was quite annoying. But luckily I was able to zoom into the speedometer in the car to show the speed out from that. And I think that that is good enough documentation to show you that we have actually fixed the main problem now with this car. And I will do some more testing, and I will just drive the car a little bit hard and then change the spark plugs, as they have been probably running really warm and had really bad combustion, as the pistons would be pretty far way down before they was getting the spark, as I was telling earlier. But before I do that, I will change the torque converter and maybe the flex plate also, because I still have this knocking sound after I tighten up the torque converter. But then I just have to wait till I get my car lift up running. But anyways, now I hope that this can be helpful for others also. No one have ever told me that this problem could be the distributor, and I have never thought of it myself either. And no one have ever told that it could be that we had not had mechanical advanced ignition timing. So this actually makes a huge difference. And actually the Ford workshop manual says that we should drip 2 drops of oil on the shaft on the distributor every time it have service. And who does that? I have to admit, I'm guilty. Never done it my whole life, and probably the previous owners of this car have never done it either. And this whole problem would have never actually, it would never have been a problem if that had been done. So that's something I have to learn from, and hopefully others also can learn from that. So hope this was useful information, and I know my English is not that good either, but I hope you understand what I am trying to tell. I can also just mention that even after I found out that I didn't have a mechanical advance, I told some people about it, and they was not convinced that I have found a problem. They were still thinking that I had problems with the injection system. So this is probably not a usual common problem. And I can also just mention that I earlier read about a person who was struggling like I did, and he had tried everything that I already have tried on my engine, and he had even replaced the whole Cagetronic system with another Cagetronic system from another car, and still the car was just idling and running smooth, and he also had the same problem, and it was like running good when he had really high RPM, and so did my car, of course. Then the engine is not struggling that much, and he actually told that he how was it, when he didn't have the throttle fully open, when he like partly had the throttle open and was like revving the engine a little bit when he was accelerating, then he could like force the engine to run better and accelerate. But my theory is that he can probably have the same problem as I have, that he don't have the mechanical advance, but when the throttle is partly open, then he gets some vacuum advance, which help a little bit. So maybe there is other people who are also struggling with this, and I hope that my other video with the Cagetronic system can be helpful for others, so they don't have to replace the whole system, because that is should not be necessary. And I can also just mention that on my way home that I tested the car in the underwater tunnel that we have here, that is 8 kilometers long, and that has a really steep hill for about 3 or 4 kilometers, and I was only able to ride at 60 kilometers an hour at the top, and it has a gradient of 8.5%. So at the bottom, even how high speed I have, or I had really high RPM, then it was running good at the bottom, but at the top it really had no performance anymore. But I could not film that because it was really dark in the tunnel, and I couldn't I didn't have any GPS signal there. But now when I did this test, it was no problems keeping the speed limit at 80 kilometers an hour, and even when I was riding in the third gear, I could still accelerate a little bit, slowly of course, but still it was no problem to accelerate. And of course when I shifted down to second gear, I had no problems to accelerate really good. So hopefully this can help others, and please tell me if this have helped you also.